Okay, Assalamualaikum and very good afternoon to all of you. It's still raining outside. I don't know the majority of you, whether you are all, majority of you are inside UTM or still in your hometown. So I don't know. Uh, so um, so this is the previous second test, 2019 and 2020 for this course 1023. And for your information, the second test has been will be delayed. Okay, so just to announce here that your second test has been delayed to, I think, January 19. Okay, if not mistaken, because I have discussed with the coordinator, Dr. Madiha. Your second test will be on 19th of January. Okay, 19th of January. Okay, so this is the sample for the previous test. As you can see, we have two questions here. The first question is on the DC circuit using a what you call a superposition, using superposition. Okay, and then the second question is on the basic Ohm's law applied to the AC circuit. Okay, but okay, so as you can see, for the second test, for the second question here, so this is AC circuits. Given the value of the resistor and also the inductor. This one is actually, this circuit is what we call, this circuit is actually in the what we call time domain. Okay, time domain, because you can see we have I, ST, I to T, VST, and so on. Okay, so this is the what we call time domain circuit. Okay, but in AC circuit for this course, and I think for if you are, we face another electrical course after this. Usually for the AC circuit, we convert. Okay, we usually analyze our AC circuit in phasor domain because it is much easier. Okay, so I hope you have got that information. Okay, because all our previous analysis, previous examples from the previous week, we have conduct our AC circuit in phasor domain. Okay, so as you can see here, you need to, first one is actually you need to calculate the combination of the impedance. Okay, so what you need to do first is actually to convert this one into a phasor. Okay, then after that you got the answer, and then you need to convert into the time domain back. Okay, before I want to discuss these questions with you today. Okay, any questions regarding the previous content, which is the mesh analysis and also the nodal analysis? Because in my YouTube channel, I have already shared with you the examples and then the solution discussion on how to solve the nodal and also mesh analysis in AC circuit. So if there is no question, then okay. Before we proceed with this example, I just want also to make an announcement about the second test. Okay, so just now I have already remind you that your second test will be on 19th of January. Oh, before that, Happy New Year to all of you. So our class is on the second day of the first of the new year. Okay. So your second test will be question number 1. It's actually not same with the previous semesters. Okay. So question number 1, if not mistaken, I also forgot. Let me look first the draft. Sharing to applications. So I need to share to unshare first. This one. Okay. Okay. The first question will be the DC theorem, which is the Thevenin circuit. Okay. So Thevenin circuit and then also some Norton circuit. Okay, Thevenin circuit I think around maybe 90%. And Norton circuit is around 10% from the first questions. Okay. So this is a DC circuit, okay? DC circuit applied using DC theorem. So Thevenin circuit and Norton circuit. So meaning that you will be given a circuit, then you need to simplify the circuit into the Thevenin circuit. Okay. So in Thevenin circuit, the main parameters that you need to know how to calculate is the V Thevenin. So V Thevenin is actually very open circuit. Okay. So meaning that if you have been given a circuit like this, okay. So your V, and then this is your load. Okay. So the first one, to get the V Thevenin, what you need to do is to actually to disconnect the load. Okay. And then calculate what is the open circuit voltage across this terminal. So VOC is actually your V Thevenin. Okay. Okay. Then the second one is your R Thevenin. So your R Thevenin is actually what you need to do is to kill all the independent source, call the dependent source. So meaning that if you have a voltage source, you need to kill. So V is equal to 0. So when V is equal to 0, meaning that this is short circuit. Okay. So calculate what is the R equivalent seen from this terminal. Okay. So and then after that, after you have completed the calculation of the V Thevenin and R Thevenin, then you need to draw what is your equivalent circuit. So this one is your V Thevenin. For the Thevenin Norton, Thevenin circuit, you need to draw the V Thevenin, which is the voltage source is in series with the R Thevenin. Okay, so this is the what we call the Thevenin circuit. And this Thevenin circuit is actually interchangeable, meaning that you can transform the V Thevenin into a Norton circuit. Okay, sorry, Thevenin circuit into a Norton circuit. So this is the Norton circuit. which is consisted of the current source, which is we call I Norton, and also the resistance Rn, where this Rn is actually equals to RTH. Okay, and actually your IN, you can, if you have already obtained the Thevenin circuit, you can directly calculate your Norton's current, which is V Thevenin over R Thevenin, because I Norton is actually I short circuit. So to get the I Norton, you need to actually short circuit the output terminal. So the current that flow through this part is the I short circuit. So I short circuit is from here, from this circuit. You know that I, this one is also I short circuit. So I is equals to V Thevenin over R Thevenin. Okay. The second question is AC circuit consisted of the sinusoidal, phasor, and basic Ohm's law. Okay. So the sinusoidal and phasor, I want to highlight something. For example, if you have been given, for example, a function, if you want to compare, for example, you have a signal which is 2 cos 10 100t, okay, 100t, and then this one is x1, and this one is x2, which is 1 sine, sorry, 1 cos 10t. Okay, so there are 3 requirements, okay, that you need to fulfill before you want to compare these two signals. Okay, the first one, you need to know, you need to make sure that the cos, the function, which is in this case is a cos function, must be, both must be in a cos function or sine function. So in this case, both are in cos function, then the first one is fulfilled. Okay, and then the second full requirement, the magnitude must be in a positive magnitude. So as you can see here, this one is also fulfilled. Okay, the third requirement, what is the third requirement? Can someone just give me, what is the third requirement?
The angular phase.
Yeah, the angular velocity, which is omega, okay, which is this one, must be in the same value. So right now, you can see this one is 100 and this one is 10. So the third requirement is not fulfilled, meaning that you cannot compare these two signals. Okay. And then, for example, also, if you have been given for example, 10 cos 1, sorry, 10, I think 10, maybe sine, okay, sine, sine 100t. Okay, so actually, you can see the omega is right now is the same, and then the magnitude is also positive, both positive. Then, so meaning that there are two requirements that met. Okay, the third requirement is actually you need to either both must be in cos or both must be in sine function. So in this case, as you can see, the x1 is cos function and x2 is sine function. So you can either convert x1 into sine function or you convert x2 into cos function. Either one. You can do both, okay? But need x1 and x2 must be in the same function. But for this course and this syllabus, so because we are using Sadiku textbook, where the Sadiku textbook use cost function as their as their what you call the main function. Okay, so we need to convert the sine into cos. Okay, so you need to use. I think if you confuse, because I have received many what I call feedback that some of you confused of my using my tips. So you can either maybe you no need to remember the trigonometry formula. Okay, it will be given in your second test. For example, the sine, you need to convert sine omega t. If what is a sine omega t is actually equals to cos omega t, I think plus 90 degrees.
Doctor,
Uh, okay, plus. Oh no, negative. Okay, so don't worry. This kind of function will be given in your second test. Okay, so please don't worry to remember or not remember this one. So it will be given. Okay,
doctor,
so sorry. Okay.
yeah, doctor, I'm confused now because in of your videos you said that you need to use only cosine, and some examples I see you solving with the sine no problem. So which one of them
Okay.
we?
Okay. Okay. Just to clarify.
I
Thank you for the
understand this the
Thank you.
difference
Yeah. Thank you for the
that you
question.
said,
Yeah.
but I mean like what to follow, which one?
For me, if you, for example, okay, because this is not the problem for you, this is also a problem for the our electrical student also. But for since you asking about this, for example, okay, for example, if you have been given a circuit where your Vs omega, sorry, your Vst is equals to 10 sine 5t, for example, and then you have your inductor, which is in the reactance value, which is 5. Okay, and then you have a resistor. Okay, 5 ohm. Okay, so what is the first step that you need to do? You need to convert into a sorry, this one you cannot see like this. I cannot. Okay, since this is time domain, so all your circuit parameters must be in time domain first. So this one, for example, maybe 20 millihenry, and this one is 5 ohm, for example. Okay, so what is the first step that you need to do? Convert, right? Convert into Phasor domain. Okay, so you need to convert the inductor first. So J, your omega is 5. So 5 multiplied with 20 milli. So what is the values? Uh, 10 milli is berapa eh? Oh, this one 100 milli. So 0.1, J 0.1, 0.1 ohm. And the resistor is remain the same, 5 ohm. Okay. Okay. So right now, so this is given to you is sine. So my question, what is the, do you need to convert into cos?
No.
Yes. No need. No need. Okay.
Yes, yes.
So you can just use 10 with an angle of 0, right? Then calculate, for example, the question is to calculate what is your IST. So this is your IS. So from here, you can calculate your IS is equals to 10, 0 with an impedance of 5 plus J 0.1. So maybe IS, I just, you need to, can you calculate for me? Because my calculator, oh, I have my big calculator here. Okay, can you see my big calculator here? Okay, so mode complex first. And then 10, if your angle is 0, then you can just leave it like this, 10 over bracket 5 plus 0.1 imaginary I. So close the bracket, you will get the answer. And then I will just convert into a polar form. Okay. So my answer is around 1.99, which is 2, with an angle of negative 1.145 degrees. Right? Okay. So the question is calculate the IS. What is your IST? So this is actually not finished yet. You need to convert back into the time domain. So your IST is, the magnitude is 2. The function that use is sine, right? So you need to use sine. Omega is 5t minus 1.145 degrees. This is correct. Okay, so right? So if the question give you in sine function, so your final answer in time domain must be sine. If the question, for example, this one is 10 cos, okay? So you need to convert into Phasor domain, which is same, which is 10 with an angle of 0, okay? And then you will get the current in Phasor domain, which is magnitude 2 with an angle of negative 1.145. Your current function in time domain is 2. You need to follow what is being given. So this one is a cos function. So 2 cos omega, sorry, not omega. This one is 5 t 1.145. So this is correct. So I hope you got what I mean. Okay. So it depends on the questions. So if the question, the original question give you in sine function, so your final answer must be in sine function. But if your question give you in cos function, your final answer must be in cos function. Okay. But for example, you are being given like this, a resistor, another 5 ohm, and then another voltage source, which is this one, maybe this one VS1, this one is VS2, 5 sine 5t. So which one to follow? Okay. The first step is to convert into a Phasor domain. But right now, since this involves 2 voltage source with different function, you need to convert either one into cos or sine function. Okay. So the rules is actually both must be in same function. But in Sadiku, all the exercise and example, he convert into a cos function. So we just follow. So meaning that this is cos and this is sine. So for the simplicity, we convert the sine into cos. Okay. So you need to convert this one. Before you convert into the Phasor domain, you need to convert this into cos function. So this one will become 5 cos 5t minus 90 degrees, right? So, and then after that, your Phasor domain equivalent, this one is still remain 0.1 ohm. This is 5 ohm, and this is also 5 ohm. This is 10, 0, and this is 5, negative 90 degrees. Okay? Then your final answer, for example, if you IS, so this one is your, sorry, This one is your IS. So for example, maybe your IS after the calculation using mesh analysis, okay, or nodal analysis. So maybe you got one -10, for example. Okay. So you need to convert back into time domain. So your IST is 1. Since you are using cos, so your final answer must be in cos function, 5t minus 10 degrees. So this is your final answer. Okay. I hope you understand this one. Yes, in my previous video, I said that it doesn't matter. Okay, it doesn't matter. For example, if you are being given a single source, for example, the previous example, single source only, so you can use either sine or cos. Okay, but for example, if you are being given two voltage sources, which is one is cos function and one is sine function. So we follow the Sadiku, where the Sadiku textbook use cos function. So we convert the sine into cos. Okay.
Okay, doctor, thank you.
Okay. So actually, that is the most important part for the AC circuit analysis, because after this, the nodal and mesh analysis actually all is actually the same. Okay. So I think that is for the tips for the question number 2. Or very expensive the the tips. Okay. Okay, so that is one is a basic Ohm's law, meaning that for if you are using basic Ohm's law, meaning that only a single source. Okay, because we cannot solve the circuit. If you are being given like this, you cannot solve using basic Ohm's law. Okay, so you need to use either nodal or mesh analysis. Okay. Okay, so we proceed with the. Okay, any question that you maybe still not clear? Okay. So after this, I will give you this copy of solution. So I think for the second questions, for the second test, will be much like this. Okay. So actually a very simple question actually. Okay. So you can see this is actually a time domain AC circuit. Okay. So which is the Vs is given in cos function. Okay. So determine the total combined impedance. So this one, what you need to do, the first step is to convert into a phasor function. It's phasor equivalent circuit. Okay, so this is, since this is cos, so just we use 100, and then the phase difference is 0, so 100 degrees. Okay, so and then since this is actually all phasor domain, so all must be in capital letter. So IS is capital, I1 is capital, I2 is capital. Okay, and there is no T, there is no bracket T, because this is phasor. Okay, there is no time variable here. Okay, so after the conversion, so you will have your circuit like this, and you will see that this 3 ohms is actually series with the inductor, and then parallel with 8 ohms. So you will obtain these values. Okay, and then calculate the IS, I1, and I2. I think you use a very basic Ohm's law, which is the KCL. Okay, IS is equal to I1 plus I2. Okay, so you will obtain, so I1 is actually, since this is the voltage is 100 ohm, 100 volt, okay, because parallel with the voltage source. So I will obtain my I1 directly in phasor 33.25 with an angle of negative 3.81. Okay. But the question want I1 in time domain, right? So you need to convert into time domain. So 33.25 cos 10t minus the 3.81. Okay. So all must be converted into time domain back, because the question is calculate IST, I1t, and I2t. Okay, so after you calculate and then you just leave it your answer like this in Phasor domain, so I just will give you half marks. Okay, because you didn't answer fully the questions. Okay, so and then IS is the summation of I1 and I2, so you just sum up this Phasor domain value. Okay, so you need to sum up using Phasor, okay, not time domain. Okay, not time domain. So all the summation, all the calculation must be in Phasor domain. Do not add up using time domain. For example, IST, you add up using this formula. So it will be very complicated. Okay, so don't use this. So all the summation, subtraction, division, or multiplication must be done in Phasor domain. Okay. For example, this one, IS is the summation of I1 and I2. So you just sum up all this, you will get the answer. Okay. So this is the answer. After you got the answer in Phasor domain, then you convert into the time domain. So the time domain is 45.7 cos 10t minus 2.76 degrees. This one, I think I will give you lah. Hold on, I think I will share with you now in the WhatsApp group this solution. Where is the WhatsApp group? Okay, this one. Okay. Okay, I have shared with you the inside our group. Okay, the last question. This one I think most important part. This is actually the uniqueness of the AC circuit compared to the DC circuit. I think some of you also still quite confused on the phasor diagram. Okay, because I received some comments and questions regarding how to sketch the phasor diagram for a given parameters. Okay, so the last question, sketch the phasor diagram for Vs and Is and determine whether the current Is leads or lag the voltage source and by how many degree. Okay, so right now, your voltage source is 100 with an angle of 0. Okay, while your current is this one, right? Is capital, this one is because in the phasor, so 45.27 with an angle of negative 2.76 degrees. So sketch the phasor diagram for both. Okay, so this is your phasor plane. We have imaginary part and real part here. So Vs is 100 at an angle of 0. So this is your angle 0. Okay. And the IS is 45.27 with an angle of negative 2.76 degrees. So negative meaning that the rotation, the angle rotation is actually in reverse, is actually in the reverse direction here. Because for positive, the direction is like this. For negative, the direction is this one. Because the phasor rotation is anti-clockwise, okay? So if the rotation is anti-clockwise, so the value is positive. So since this one is actually negative 2.67, so you need to draw the current using at this picture like this, okay? So if you can see like right now, because the rotation of the phasor is like this, so if you put your eyes here, so you will see Vs first, and then the second is Is, right? So meaning that your Is is lagging Vs. That is how we determine whether the Is is leading or the Vs is 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 lagging or Is is leading. Okay. So when Is is leading, so your phasor diagram should be like this. So this one is your Vs, maybe this one Vs, and your Is maybe here. Okay, this one positive, maybe 45 degrees. So I can say, so if I put my eyes here, okay, I can say that I will, when the rotation is like this, I will say that I will see Is first. And then the second one is Vs. So meaning that I is leading the voltage. By how many degrees? For this question, how many degrees the Is is lagging is actually you refer to the difference between the voltage angle and the current angle. So right now the voltage angle is 0 and the current angle is negative 2.76. Okay, so you just put only the magnitude only. Okay, do not put negative or the sign. Okay, you just put the magnitude. So I can say that Is led the Vs by 2.76 degrees only. Okay, so meaning that if you put the information like this, so the engineer knows. Okay, so the Is will be behind the Vs. Okay, so it depends. This actually this angle is depends on the difference between Vs and also Is values. The angle. Okay, and then for example, maybe this one. This is my Vs. Okay, my angle maybe this one is 60 degrees positive, and my Is maybe negative 45 degrees. Okay, so I can say that my Is is lagging Vs by how many degrees? You total up all this. What is
105.
the angle difference is 100. 5 degrees. Okay. And then another example. This one is too thick. Okay. Another example, if I have, for example, like this, my VS is maybe negative 60 degrees and my IS is negative 20 degrees. Okay, for example. So I can say that my IS is leading or lagging right now. If I put my eyes here, then the rotation is like this.
Leading.
Yes, is leading. By how many degrees? So you need to calculate the angle here between IS and VS. So right now the angle here is 40 degrees, right? So 40 degrees. So IS is leading. Okay. IS has a difference between the phasor difference is between IS and VS is 40 degrees. Right? So IS is leading VS by 40 degrees. Okay? Okay. Can someone tell me what week that we are right now? The number of week. You tak ingat ke? You pun tak tahu. What number of week that we are right now?
12. 12, I think.
12. The original is 12, right? So we have another 3 weeks more. Okay, 3 weeks more. And then for your information, so the last week the class is suspended and because of the flood. Okay, most of the reason is because most of our students, I don't know, maybe during maybe from the feedback or maybe from the database that the UTM have collected. So majority of the local Malaysian student are affected with the flood. And then I think most of our students also involved in the volunteer scheme where they went there to the flood states to help the victims and so on. And I if not mistaken, they will come back to UTM on today. Okay, so that's why they suspended the class, and we as a lecturer we don't know what is the action taken by the university, whether they will extend the calendar academic or not, because we have lost 1 week. Okay, so we don't know whether the last week class, whether the lecturer need to replace it. Okay, and then the lecturer need to find the slots by themselves, or the UTM, the university, will actually extend the academic calendar by 1 week. I don't know. So we are still in the gray area. So by at this time, it looks like there is no extension of the calendar academic. So um, meaning that we just follow the original calendar. Okay. So that is right now the situation lah. Okay. So I will leave you after this the pre-recorded video. So right after because in the previous week I have already shared with you the mesh analysis and also the nodal analysis. Okay, and then so by today I will share with you the what else? The superposition theorem. Okay, the superposition theorem. Superposition theorem ke? No, sorry. I think what we have left, I think superposition, yes. Superposition, we are only left to superposition theorem for the AC circuit and also the Thevenin and also the Norton circuit. Thevenin and Norton theorem for the AC circuit. That is the only 3 topics that we are still not covered yet. But as you know, the theory behind it is actually similar to the DC circuit. Okay, the only difference is actually it involves the complex numbers and so on. Okay, so I think we dismiss our class. If you don't have any question regarding the mesh and nodal analysis, okay, so I think we dismiss this class, and then you continue with the I will upload after this the superposition theorem, and then okay, sorry. Yes, I will upload the superposition theorem video after this. Okay. Okay. And then by tomorrow, I will assess you. I will give you an assessment. You need to do it online because that assessment is actually to see how you communicate to each other to solve the problem. Okay. By today, I will give you the list of the group. And then by tomorrow, I will give each group in the breakout room. So each group need to solve one problem that I will give you tomorrow. To solve it online. So I will actually want to see how you communicate. Okay? How you communicate to your friends to solve the problem.
Tomorrow, doctor?
Yes, tomorrow on Monday, right? Our class is next is on Monday. So the question will be on the I think will be random. So some of you will get DC circuit. Some of you will get AC circuit, but the AC circuit will be a very simpler one. Okay, just a AC, what you call just an basic Ohm's law and so on. Okay, by tomorrow. So tomorrow, so please make sure that you present because the assessment will be made online. Okay, so I will divide you into breakout room. Okay, then you need to do the communication online. Okay. Okay.
Doctor,
Thank you
any
very
mark?
much. Okay.
Doctor,
Sorry.
is it considered any mark? Is it
Sorry.
considered any mark? Any mark is it considered?
Yes,
Or,
because
oh,
that is under I think maybe 10 or 5% from your total marks.
okay, doctor. Thank you.
Okay. Because if you look carefully on the course information, there will be an assessment on how you communicate. Okay. In face-to-face class, no problem because we have the online we have the what you call in-class activity, so I can assess you based on class. But this problem is actually we are online, so the problem is how can I assess you online? So I think that is the only way. Okay. Okay. Yes. Final will take you 50%. 50%. Okay. Okay. So thank you very much for all your cooperation. So meet you tomorrow. Okay, Assalamualaikum and have a very good day.
Thank you, doctor.